Hello guys and welcome. I hope that you're having a good day or good morning or good evening. Happy holidays, by the way. My name is I play 4K, AK I play AK, AK I play 16K or UHD King. During this video today I'm going to show you Cyberpunk 2077 running on my workstation that is equipped with the old school Xeon E5-2697 V2 CPU and a Titan RTX single video card with 24 GB of the VRAM. Let me real quick go ahead and show you the system first, and then I'm going to show you a benchmark Cyberpunk 2077 for the first time running on 12K resolution. We're going to go with the lowest possible presets and we're gonna go all the way up until the game will freeze up, because the game will freeze up. 12K resolution for the single Titan RTX is too much in Cyberpunk 2077, but we're just curious how far we can push it. And the reason of this video is not the gameplay, the reason of this video is a benchmark, so we can bench it against the next generation of the hardware such as video card, CPUs and workstations and gaming PCs. But this is a workstation, this is not my gaming PC. Okay, so as you can see, I just zoom in 300% on magnifier. Okay, but let me real quick go ahead and show you my system. Look like I need to zoom in a little bit more. So this is the system, guys. It's running 3.2 gigahertz per each core. It's running 12 core, 24 threads. The Xeon E5-2697 V2 from 2013. In 2014 it costs about $2,500. Great workstation if you're looking even in 2021 for the video encoding, video transcoding or 3D rendering. I picked up the CPUs like new on the eBay for $129 in the beginning of 2020, before the crisis, before the health crisis, before the virus. And in 2021, in the end of 2021, the CPU will cost around $79, and pick up two of those on a Chinese dual socket motherboard will be a great idea for the 3D rendering station or video transcoding, video encoding station. Usually I do 8K resolution to 8K resolution video conversions or 3D rendering of my projects. So here we go. As you can see, it's running on the gaming motherboard from 2014 that I used the i7-4930K X79 UD3 version 1.1, not version 1.0, and with F20 BIOS. You gotta update the BIOS first and then install the CPU, otherwise it's not going to post, not going to boot. Okay, it's BIOS available from the Gigabyte website from March 19, 2014. Titan RTX today running 16 lanes on the PCI Express 3.0. I have 32 gigabyte DDR3. It's DDR3 unfortunately, but quad channel 256-bit, and it's running 1120 megahertz unfortunately, even if this memory is unbuffered 1600 megahertz CL9, but it's unstable at 1600. It's stable at 1420 megahertz but crashing sometimes, so this is not crashing at all at CL9. And this memory 256-bit 4 sticks 8 gigabytes is equal to DDR4 2133 megahertz CL18 on my i9 9900K. Keep that in mind. Okay, and as again, Titan RTX right now is sitting at stock with the 24 gigabyte of VRAM GDDR6, but I'm going to overclock. I'm going to overclock my memory to 8000 megahertz, which will be times 2, 16,000 megahertz, and the GPU I'm going to overclock additionally by 100 megahertz. Okay, guys, and yeah, this is how the OpenCL under the IDA64 scored with this CPU at this frequency and with the Titan RTX running completely stock. OpenCL is a great benchmark for us to compare CPU versus the GPU, and this is how the CPU scored is again under the IDA64. Okay, pretty much that's it, guys. Oh yeah, let me show you, very important too, let me close that my desktop today is sitting at 12K resolution as well. Okay, and what kind of 12K resolution it is? It's going to be 3 8K resolution monitors in a vertical. So we're using their vertical 7680 pixels as our horizontal, and three of them, height of 3 times height of that 8K resolution monitors displays we're using as total 12K resolution. How I achieve that? I'm using 8K resolution native screen plus DSR. I can run 16K resolution, or I can run like this 12K resolution. Okay, 100% scale. Okay, let me close that. Okay, pretty much that's it. Let's go ahead and back into the game. Let me show you the settings, and let me actually overclock the video card as well under the MSI Afterburner. So I'm going to use my profile, which is 100 megahertz additional on the GPU and 2000 megahertz additional on the VRAM. Even if it says 1000 megahertz additional on the VRAM, we gotta multiply it by 2. So it's going to be not 14,000 megahertz, but it's going to be 16,000 megahertz, and the GPU Z going to show us now much higher capabilities, much higher pixel fill rate, which is 179.5 gigapixels, textual fill rate 528 gigatasks, and the bandwidth is 768 gigabytes per second. Go ahead and rewind it. You're gonna see those values will be much less than right now over here. Okay, let's go ahead and jump back into the game. So I'm still using the zoom. Let me zoom out a little bit. So we're going to start with the lowest possible preset, and I'm just want to test the Titan RTX single video card on this workstation, just a demonstration for you that it's not necessary to have the fastest CPU. It's necessary to have the fastest video cards, or one of the fastest video cards, but CPU can be anything, and this CPU is enterprise. It's not gaming CPU with a lot of threads. Also, I'm going to use a lot of threads just to show you how many threads this game is utilizing during the gameplay, which is also a great value for you. And we're going to start multiple benchmarks. I'm going to start with everything low, and we're going to go up until the game will freeze up, because 12K resolution for single Titan RTX is too much if we're going to pretty much increase the visual presets. So pretty much it's going to be like this, guys. The texture set at low, texture quality at low, even if it doesn't show so because I'm already in the game, it's set at low. But when I'm going to switch, I'm going to show you also the texture quality at high. Texture quality low and high doesn't matter at all in terms of our FPS, but it's a little bit overstressing our VRAM, okay, when you're switching high and low. So as you can see, everything maximum possible lowest presets, guys. I'm coming in real time, okay. So retracing will be on, but retrace reflection off, retrace shadows off, and retrace lighting is off. Pretty much it's like it's off completely, RT, but it's still kind of doing some retracing. It's not running the completely without the retracing thing. DLSS, this is NVIDIA technology that designed to boost up the performance. So ultra performance will be in the Cyberpunk 2077, the maximum possible FPS in the game, but the reflection and refraction going to be at much slower resolution, not at the 12K resolution, but at, I believe, like 1080p, something like that, at ultra performance, or even maybe lower than that. Okay, but when I'm going to do the performance, it's going to be higher than that, probably 1080p. The balance will be probably 1440p, and the quality probably will be 4K or something like that, but it's not going to be, guys, at 12K resolution. And auto will be like computer AI will change it by itself, and off will be completely 12K resolution, which is unheard of for the retracing. But anyways, we're gonna start it like that. I already load up the game. Okay, so this is how we're going to start, and as again 12K resolution. Let's go ahead and have a look, shall we? Windowed borderless mode, but for DirectX 12 API under Windows 10 it doesn't matter, because Windows 10, even the windowed mode, using the DirectX API. It's not like on Windows XP, windowed mode is not the same as a full screen. On Windows 10, it's going to be the same as a full screen in terms of the FPS. Okay, so I'm going to apply that. The reason why I'm showing you, this is, by the way, how the 4K resolution looks like in the windowed mode on the 12K resolution desktop. When I'm going to apply, you will see it in a second. The in the December 10, 2020. Today is December 10, 2020. Actually, today is December 11, 2020, the second day when Cyberpunk 2077 was released for the users, for the gamers. And as you can see, the menu is breaking up. So the reason why I did it, so we're gonna see what's going on. Okay, so I'm going to go ahead and exit now, and let's go ahead and have a look. As you can see, those dots as a noise means that our DLSS at minimum possible preset in terms of the visuals. And you can see on edges of the mirrors as well the noise. I'm playing as a street kid, and this is the beginning of the game. Forgot to enable the, let me actually to start it over, guys. I forgot to enable the, yeah, let me start it over. So I'm going to quit the menu. As you can see, menu is still okay over here, but then it's going to flicker again. So it's a bug. It's what developer didn't do a good job, unfortunately, and it is what it is. So I'm going to go ahead and bring it back real quick. We're going to reload completely. I'm just going to start a new game. Okay. The game looked like a Deus Ex. If you are a fan of that, it's kind of similar to that, but only this game is consumed much higher performance. Oh, look at this. Oops. So it's appearing, disappearing, and it happens, guys, after the 4K resolution, and it's a bug. Hopefully they're going to fix that. Let me select the man. Here we go. Okay, let's load up the game. Make sure this time we have the stats available. At the left top corner, guys, very important, you want to focus your eye at the video RAM, at the system RAM, and at the GPU utilization, as well as the CPU utilization. And as you can see, I put for you all the 24 threads, which is 24 virtual cores in the Windows, but this CPU comes with the 12 physical cores plus the hyper threading technology, which is additional 12 virtual cores. So 24 virtual cores in Windows, 17 FPS, not bad, not bad. 18, almost 19 gigabytes of VRAM usage, which is 18,000 megabytes, as you can see at the left top, and the system RAM usage is almost 12,000 megabytes, which is 12 gigabytes. As again, the total system RAM usage is allowed 32 gigabytes, but when we're gonna see when the NVIDIA driver will offloading some data from the VRAM into the system RAM, it's not going to happen till 32 gigabytes. It's going to happen till probably 5 or 6 gigabytes, and after that point the game going to crash. So thanks God that NVIDIA is still offloading some data from the VRAM to the system RAM when we're going to overload our VRAM, but it's not going to help us in terms of the great performance in the game. You will see the performance will drop immediately, but it's not crashing the game, so thanks to the NVIDIA. Okay, the game is not bad, but I think I thought it was going to be much better. So the game had a great marketing, and it's looked like Deus Ex from 2016, guys, to be honest with you, in terms of the visuals. Okay, so this is minimum possible visuals, guys. Okay, with DLSS at the maximum performance. Let's go ahead and walk up a little bit. Here we go. And I'm going to cut it, guys, and I'm going to switch the presets. So I'm going to edit this video. I'm going to create multiple shadow play recordings. So it's recorded with shadow play, keep that in mind, on the same computer. So please add 3 FPS to the FPS counter without the shadow play recording on the same computer in real time. So I'm not recording with external device this video. Okay, 17, 19 FPS. Without it, it's going to be like 21. Not bad for Titan RTX, don't you think, guys? But it's overclocked Titan RTX. As you can see, the VRAM usage below 19,000 megabytes and the system RAM usage below 12,000 megabytes at the left top corner. Wow, it's utilizing all the threads. This is the first game actually that's utilizing 24 threads that I saw. Alright guys, I'm going to go ahead and quit this video and I will reboot the game with the new settings and I will see you in a second. Alright guys, so I just rebooted the game and this is what we have. So let me show it to you. Okay, same deal over here. 12K and which is 3 8K resolution monitors. The texture quality will be still at low, guys, keep that in mind, but it doesn't matter, low or high. It will just a little bit higher VRAM usage, but doesn't matter in terms of the performance, in terms of the FPS. Maybe 1 FPS lower will be with texture quality at high, which is very recommended for you, because what's the point to play it at 12K resolution, texture quality at low. But as again, this is a benchmark, this is not the gameplay. So this is how we're gonna do it, guys. Okay, now I switch the DLSS to the performance. Okay, so let's go ahead and apply and let me zoom out. We're gonna get to the game. Immediately, as you can see, 13 FPS, so we just lost about 6 FPS. Still on the table, we can see the noise. Please watch this video, guys, at least at 4K resolution. Just switch in your YouTube video player. Still noise on the edges of the mirror. As you can see, 12K resolution, even with the texture quality at low, it doesn't look that bad, because the amount of the pixels and the 12K resolution, we're rendering every single texture. Not that bad, as you can see. But as again, if I would play it 12K resolution, of course textures, I will have the maxed out quality. Okay, so lost about 4 FPS in preset, so you can compute the percentage. What will be FPS loss between the settings. Adjust the DLSS, guys. Keep in mind that everything is still at the minimum visuals. And look how this game looks at the minimum visuals, not so bad, huh? During this video will be, guys, long, about 40-50 minutes, so go ahead and grab yourself your favorite drink. I advise you to drink the water with the lemon. It's the healthiest drink ever. If you will drink water with the lemon every day for 3 weeks straight, you will get so healthy after 3 weeks, it's going to be amazing. Okay, so 12 FPS, I'm not advising you to drink beer or something like that, it's unhealthy. Even coffee, a lot of coffee is unhealthy. But tea instead of water with the lemon is a great idea. So 13 FPS, guys, as again recording with the shadow play, so please add 3 FPS. Not so bad. Too bad that this is DirectX 12 API that doesn't support the Titan RTX SLI, so it doesn't support 2 video cards, Titan RTX and SLI, or 2 RTX 3090 SLI doesn't support it. This is too bad. If I would be the developer, I would develop it under the Vulkan API, and Vulkan API version 1.1 supporting SLI. Otherwise, it would be a great FPS. It would be like around 22 FPS with the two right now, with the 2 Titan RTXs and SLI, because pretty much 2 Titan RTXs and SLI at 99% utilization gives you 1.9 times boost in terms of the FPS. Alright, so we got an idea, right? The GPU utilization is excellent, 99%. The video card thermal throttling a little bit, so it's lowering the temperature by lowering the frequencies of the GPU. Otherwise it would be running 2050 megahertz with this overclock. Okay, so I'm going to go ahead and stop on that. Let me go ahead and reboot the game, and I'm going to show you DLSS at the, I believe it's balanced mode. In a second, I will see you guys in a second. Alright guys, I'm back. So I just rebooted the game completely and did the preset that we want to see. Let me zoom in a little bit. Guys, imagine to run this game at 16K resolution. Hopefully it's going to be runnable or benchable at 16K resolution, everything at low. If it will be the case, it's going to be another video for you available over the UHDking.com YouTube channel or iplay16k.com YouTube channel. Go ahead and check it out. But anyways, so as again, the texture preset at low, it doesn't show here because I'm in the game right now, but it's set at low, still at low. So everything else is also lowest possible presets. Okay, and the DLSS at balance now. So it's going to bring us much better visuals, but going to decrease the FPS. Okay, so let's go ahead and back into the game and let's go back into our testing. Let me go ahead and apply that. Let me zoom out. And here we go. Hopefully they're going to fix this menu because it's happening after 4K resolution and this is annoying. The developers didn't test this game right. As again, this is the beginning of the game. If you're playing the straight kit, still noisy but less noise though, as you can see, and still noisy on edges but not that much noise. 10 FPS. FPS is decreased, as you can see. Most definitely. Okay. I'm just, guys, decided to go ahead and show you all the possible presets until the game is going to freeze up. And I know it's going to freeze up at the DLSS off. But before I'm going to switch to DLSS off, it's going to be the last benchmark test during this video. I'm going to show you every single visuals at the maximum as well, and but DLSS at the lowest possible, because it doesn't matter what kind of reflection and refraction we have under the retracing. If we have them, it's nice, but we're going to go ahead and have a look at this. At our VRAM utilization, almost 21,000 megabytes at the left top, and the system RAM utilization is almost 12,000 megabytes. Okay, great utilization in terms of the threads. This is one of the first games that utilizing all the threads on the CPU available, up to 24, and I think it's going to utilize even above 24 threads. But as again, it doesn't mean that you need to have 24 threads for the CPU to run maximum FPS. You want to keep your eye at the overall CPU utilization, and when your overall CPU utilization is below 90% and our overall CPU utilization not even 25%, I didn't see the 25%, that means that we can disable some cores in hope that we can increase some frequency on our CPU, and we're going to benefit more, okay, in terms of the FPS result, final result. And this CPU has lock multipliers, and turbo boost is automatically controlled by the Intel CPU. So to be able to increase the multiplier, just like I overclock my CPU, as you can see, I need to lower the, I need to go to 4 threads, but as you can see, it's probably possible to run 4 threads, but utilization probably will be at 80%, something like that. So you want to make sure that you're not going to reach above 90% during the gameplay, otherwise you're just losing your FPS, guys. Okay, you just need to add additional 2 cores. Otherwise, the Windows operating system and NVIDIA drivers will limit you in terms of the FPS. But when your CPU utilization below 90%, the driver is not limiting you in terms of the FPS at all. Even, you know, if it's can utilize even 24 threads, but it doesn't matter. I'm pretty sure that 6 cores, 6 threads will be more than enough in this game at this resolution though. The higher resolution, the less CPU cores, CPU threads needed, guys, keep that in mind. The lower resolution, the higher threads and higher cores needed. So at the lower resolution, you definitely will take advantage. As you can see right here, the retracing materials, as you can see, also having some bug at 12K resolution, and I believe the texture materials are not unlimited like in regular games when using retracing, and this is, I believe, the problem of the retracing DirectX 12 API retracing feature of the Microsoft. Hopefully they're going to fix it, because I saw this in many games when I was running above 4K resolution. And I believe, see that reflecting materials that using the retracing capabilities right here. So as again, the retracing games are not ready above 4K resolution yet, even if you have the hardware that capable to do that, because you're going to end up on a retracing material, something to like that. See that gray, the tubes right there, gray material. Alright, hopefully Microsoft also going to fix this bug, but hopefully the developers of the Cyberpunk will fix their menu. Alright guys, let me go ahead and shut it down, and I'm gonna reboot the game, and let me go ahead and switch it now to DLSS under the quality, which is the maximum possible quality preset for the DLSS NVIDIA technology to boost up our FPS. I will see you guys in a second. Alright guys, I just changed the settings, rebooted the game, and now we're going to try the quality preset. Let me real quick go ahead and show it to you. As again, texture quality still at low, and every single settings, as you can see, at lowest possible settings. We're about to change that before I'm going to completely turn off the DLSS, make it off. But quality preset, okay, 12K resolution. Let's go ahead and have a look, shall we? Let me zoom out, back to the game. Okay, wow, 9 FPS. So pretty much quality versus the balance, almost the same deal. But we improved, not improved, we are using much more or higher value of the VRAM, as you can see, and a little bit higher value of the system RAM. The latency delay in terms of the milliseconds by the FPS is also very high. We want to keep that value as low as possible. It's latency delay in terms of milliseconds, that MS by the FPS, but FPS we want to keep as high as possible. 30 FPS is a comfortable gameplay for old school gamers, but 60 FPS kind of for all kind of gamers will be comfortable FPS. As again, this is not the playable settings, this is the benchmarkable settings, so we can benchmark it in the future, and this is the reason of this video, and see what's the difference between the hardware evolution. Okay, look at that low CPU utilization. I even didn't see the 20% yet of the CPU utilization. Okay, so I'm pretty sure that i9-9900K, which is my gaming rig, will be good to go at 5.3 GHz with 6 core 6 threads with Titan RTX over here. Look at his fingers, you can see the low quality textures, definitely not showing his nails proper. The textures are not there. Okay, this game is using a lot of swearing, so if you have a little kid, probably this is not the game for him to play. Keep that in mind. And that Deus Ex will be much better game at my point. They just had a great marketing team, guys. The game doesn't look that good. I mean, it's going to be popular and trending, but if you're a smart guy, you probably will skip on that, especially if you have the low grade hardware, because as you can see, it's required a lot of hardware to run. Keep in mind, I'm going to show you more different resolution on the Xeon E5-2697 V2 on my workstation in this game as well, and plus I'm going to show you on my gaming rig, so we can compare the difference in terms of the CPU from 2014 and top dog CPU from 2018 gaming CPU, and what will be the difference. Of course, I can increase the FPS, the frequency of this CPU by just do 4 core 4 threads, but I think that 4 core 4 threads at the boost 3.4 GHz, which is 200 MHz additional boost, is not going to be good enough. And this CPU is also overclocked by 200 MHz additional, the Xeon E5-2697 V2, through the BCLK, not through the multiplier, but through the BCLK. I overclocked the BCLK from 100 MHz to 106 MHz, and gave me additional 200 MHz at any multiplier, at any automatic turbo boost. Unfortunately, as again, I cannot control the multiplier to overclock it even further, otherwise the CPU will be golden. The V3 series, guys, you can overclock to the, you can force the maximum multiplier, and I'm looking to get myself 2699 V3, two of them on Chinese dual socket motherboard, and hack the BIOS so I can force the maximum turbo boost at 3.6 GHz on those two 2699 V3 CPUs with the total 72 threads. It's going to be probably amazing 3D rendering and the video encoding system that nobody yet tested, and I think it's going to destroy the Ryzen R9 5950X. And Ryzen R9 5950X right now in 2020, in December 2020, costs $900, which is unbelievable expensive. And I was offered on the recycling company $129 for the 2699 V3 used like new CPUs for a single one. So two will cost me like $300 plus the motherboard around $200. For $500 I can build myself the whole system and spare the DDR4 from my PCs. Alright guys, so you saw it. Not bad. This is a quality. Okay, I'm going to go ahead and wrap it up right now with the lowest, and right now I'm going to switch to the highest possible preset, but still I'm going to use the DLSS at the maximum performance. But the texture quality will be at high now. But this test had the texture quality at low. I will see you in a second. Alright guys, I just set the preset, rebooted the game. So let me zoom in and show it to you. Please watch this video at least at 4K resolution. Just switch in your video player. So quick preset, I set to ultra, and I set the textures at high. Okay, it's low, medium, and high. And it says custom because at ultra preset the DLSS comes at off. But I use the ultra preset, but I set the DLSS at maximum performance, which is using the lowest possible quality by the NVIDIA feature DLSS, but the highest possible FPS. Okay, so this is how we're going to run. So the last test before I'm going to make DLSS off, and we're going to overload our VRAM. But just go ahead and have a look how it's going to look like. So everything else is maximum possible preset, as you can see. Okay, at ultra, preset at ultra. Let's go ahead guys and do the benchmark, apply, here we go. Now look at this, immediately jump to the VRAM to 22,000, almost 23,000 megabytes at the left top. Yep, just reached the 23 almost 1,000 megabytes, and the system RAM is also almost 12,000 megabytes. So I can assume that we're overloading right now our VRAM data, and pretty much the driver before the overload happens offloading some data into the system RAM, and about right now it's 12,000 megabytes as you saw those kind of lagging out. So about 1 gigabytes of the data offloaded from the VRAM into the system RAM to avoid any crashes, I believe. And NVIDIA driver is predicting the crash, so it's doing in advance. So it didn't reach that 24,000 megabytes yet, but driver decided to offload the data in advance to make sure that it's not going to crash. Completely makes sense. 11 FPS, so, and maximum performance on the DLSS. So pretty much at high, before at low it was 17, it was 19, and at high it's 10, 11. So we lost about 8 FPS. Everything else at maximum possible visuals, as you can see. Okay, very high VRAM usage. Okay, so I would say to play this game above 8K resolution comfortably, you will need to have 32 gigabyte of the VRAM. Okay, and of course the power should be 3 times of the Titan RTX, which will be pretty much 2 times of the RTX 3090 video card. And unfortunately this DirectX 12 API doesn't support SLI like all other DirectX 12 APIs. So it's supporting multiple video cards but not the SLI, and unfortunately the developers didn't make sure that it's going to support multiple video cards without the SLI capabilities and bridge, so it's not supported in this particular game. Even if DirectX 12 supporting multiple video cards, but this again doesn't support the SLI ability of the multiple cards under DirectX 12. So pretty bad. Too bad that they didn't use the Vulkan API version 1.1. Otherwise we would boost up with RTX 3090 two of those video cards in SLI, probably receiving 30 FPS right now, which will be amazing at 12K resolution. Just amazing. Beautiful visuals, by the way. The visuals are amazing. Check it out, guys. So, alright, 12 FPS. VRM usage went, look at this, the VRM usage went below 19,000 megabytes. So I'm pretty sure that the driver takes a lot of data. Instead of loading it into the VRAM, it's loading it into system RAM, because the VRAM usage should be way above 20,000 megabytes at the left top corner, as you can see. So I'm pretty sure we're offloading like 2 gigabytes right now from the VRAM into the system RAM to avoid the crash. But probably it wouldn't crash, it still wouldn't crash it at this type of scenario, but driver decided to do so just in case, so the game still will be runnable. But when it's doing so, milliseconds latency delay is increasing by a lot, so it's kind of slower and it's creating that kind of lag. And when you see 190 milliseconds of your latency delay in the games, that for sure that VRAM data is offloaded into the system RAM in about like 2 gigabytes. When you see like above 300 milliseconds, it means that we are offloading 3 gigabytes. This is based on my experience running a lot of games under the over the 8K resolution on the Titan RTX, on the Titan XPs, on the Titan X Maxwells, on the GTX 1080 Ti, on the RTX 2080 Ti. Alright, so we saw that. Okay, let me go ahead and quit that. And now I'm going to turn out the DLSS, and I'm going to turn off the maximum possible visuals. So I'm going to bring the visuals back to lowest possible and turn off the DLSS. I will see you guys in a second. Let me reboot the game and do the settings. Alright guys, I just set the settings, rebooted the game, and we're here. So let me zoom in. And yeah, let's go ahead and have a look. Everything's set at the lowest possible settings. Textures quality is also set at low, even if it doesn't show here, just to save an extra additional VRAM. And as again, VRAM is equals to video RAM. If you are a beginner, so you will fully understand, and system RAM is our RAM. Okay, here we go. This is the settings. DLSS is off, so pretty much it's going to use the 12K resolution of the retracing capabilities. Even if the retracing is not off, not completely off, as you can see, this is what's up. Okay, at this point, so this is the settings. So use the low preset. Let's go ahead and have a look at this benchmark. Let me zoom out, accept. And this is a very smart build, guys, this computer, because it's a workstation and the best in terms of the performance versus the money. But I wish I would have 2 of them, and I wish the multiplier would be unlocked. So, or I can force the maximum turbo boost on the V2 Xeon E5 2600 CPUs, but it's not going to happen because it's locked. But version 3.0 2600 Xeon E5 version 3 is possible, and hopefully I'm gonna get those CPU 2699 V3, 2 of them, on the dual socket motherboard. I'm still thinking what to get, R9 5950X, or for overall for the gaming and rendering for everything, or for just my rendering station, 22699 V3 CPUs with unlock multiplier 3.6 constantly, 3.6 gigahertz constantly per each core, per each thread. Nobody show you guys yet that, but look at this DLSS without any noise over here on the mirror edges. DLSS is off, 12K resolution going on here. It's still some retracing capabilities enabled right now. 4 FPS, not bad, not bad. With the shadow play recording at the same time. Wow, it's handling it not bad, but as you can see, my latency is above 200 milliseconds, so we are uploading a lot of data, and the system RAM usage right now is almost 15,000 megabytes at the left top corner, and the VRAM usage is almost 22,000 megabytes, and it's already offloading about 4 gigabytes into the system RAM, so it's about to crash it. I think the maximum what I saw during my experience in PC games over the 8K resolution, it was like 5 gigabytes offload from the VRAM into the system RAM by NVIDIA driver, and after that point everything was crashing. With the error, system RAM error, not enough, and pretty much this is what DirectX API thinking, but pretty much because the NVIDIA driver is managing like that. But system RAM is enough. I have 32,000 megabytes of total system RAM, which is 32 gigabytes, but the VRAM is not enough because it's kind of handling it through the pipeline of the rendering DirectX API, NVIDIA driver. So I'm pretty sure right now over here we're using about 26 gigabytes of our VRAM, and the only thing we're going to find out when we're going to test it on the next generation of the NVIDIA GPUs, which will be not the Ampere, which will be next after the Ampere, that will feature, I believe, 32 or 36 gigabyte of the VRAM. We're going to find out, but I think at this type of right now everything at lowest settings, textures at low, and DLSS is off, but still retracing is on, as you saw it, but kind of on. It's not off, but kind of on, but as again not all the features are used. I think 26 gigabyte of VRAM or 26,000 megabytes of VRAM is utilized based on our system RAM utilization. When I'm playing this game at 4K resolution, the system RAM utilization is 10,000 megabytes, and I think it should be the same case at 12K, 16K, at any kind of resolution, because the system RAM capacity doesn't matter when you're playing. Any resolution is going to be the same unless it's offloading some data from the VRAM into the system RAM, and this is the case. Because during the rendering right now we're utilizing the VRAM and the GPU computing performance, and the system RAM is kind of load up from the beginning of the level, and it's supposed to hold that data, and that's it. Nothing else should be happening. Not bad, guys. 7 FPS. I thought it's going to overload our Titan RTX, but it didn't. I thought it was going to be like 1 FPS and that's it. It didn't. So I'm going to run one more test after this video. One more. I'm going to switch the retracing to low. I believe to low or medium. We're going to find out. And everything else I'm going to switch to lowest possible settings. And DLSS I'm going to bring to maximum performance. We're going to see if it's going to run it or not. But retracing at medium. This is going to be the last test, and we're going to go ahead and wrap it up, guys. So pretty much the first 12K resolution video of the Cyberpunk 2077, not like those copycats that are going to copy each other, 8K resolution, and probably for a long time the last one, because it's required some programming skills to be able to use the NVIDIA native DSR above 8K resolution. And today, as again, I'm using NVIDIA native DSR on 8K resolution screen with NVIDIA native DSR to 12K resolution. Hopefully we can run something at 16K resolution, and if this will be the case, I will upload that video for you and share with you over the UHDking.com or iplay4k.com or iplay16k.com YouTube channel. Okay, so don't miss it out. Not bad, guys, not bad. Runnable. So RTX 3090 should be showing here around 12 FPS at this type of preset right now. Okay, let me go ahead and cancel that, and let's go ahead and do one more thing. Retracing at medium, but everything else at low, and DLSS at maximum performance. I will see you in 1 second. Alright guys, I'm here. So I did the settings, rebooted the game. So let me zoom in. So this is going to be the last test. So this is how we're going to roll. Everything set at low, but retracing at medium, but every other settings at lowest possible settings, as you can see. I couldn't believe that we were running every single setting at ultra during our third, I believe, or fourth benchmark, just before the previous one. Look at this. Retracing on, retrace reflection off, so no reflection, but retrace shadows is on, medium lighting, ultra performance though under the DLSS. Let's go ahead and have a look, shall we, guys? So this is how we're going to run it. This is going to be the last test, as again you just watched the first 12K resolution Cyberpunk 2077. Don't forget to smash that like button, subscribe, share it with the friends, and let me real quick go ahead and enable that, disable the zoom. Hopefully we're not gonna overload our VRAM, but we're going to find out. As again, hopefully they're going to fix that menu because it's ridiculous. Wow, look at that. Look at that FPS. So RTX 3090 over here will showing about 19 FPS. Wow, not bad. So pretty much 2 RTX 3090 and SLI would be able to run this game at this preset at 12K resolution. Wow. Wow, wow, wow. And the VRAM utilization is not that high though. You know what, guys? Let me go ahead and do one more test, but we're going to enable the reflection. Everything will be at low as again, but with the reflection is on under the retracing. I just want to see what's going on. So it's going to be retracing medium, but with the reflection on. I'm just curious how it's going to be. I know the DLSS at maximum performance, but come on. We don't have too much of the VRAM. We almost brought our VRAM to the 24,000 megabytes. As you can see, the maximum capabilities of the Titan RTX, which is 24,000, I believe, 400 something, 464, something like that, 24,464 megabytes of total VRAM of the Titan RTX. But when it's going above 24,000 megabytes, it's starting lagging out, guys, before it's reaching the maximum limit. And I think the driver is panicking at that point. So guys, I explained to you as the software developer with experience since 2007, web developer with experience since 2000, graphics designer with experience since 1999, gamer since 1997, PC hardware enthusiast since 1997, and PC overclocker since 1999. A lot of information was shared with you guys. Hopefully you appreciate this video. It's not like those copycats that repeating itself, and this is very unique video, so don't forget to smash that like button. My FPS is so high, so I want to do one more test, guys. I want to do that reflection at medium, but with the reflection is on, retracing at medium, but with the reflection is on, but everything else at the lowest possible preset, which at 12K resolution, lowest possible preset looks amazing, guys. Even the texture quality at low preset, as you can see right now, but still not bad. At high preset, probably we're gonna see the tattoos over here in the skin, but not so bad at 12K resolution, the texture details. Alright, so let's go ahead and do that, guys. I will see you in a second. Hopefully we're not gonna overload our VRAM. Alright guys, I'm back. So preset is ready. I rebooted the game. Let me zoom in. Okay, so this is how we're going to have it, guys. Everything at lowest possible settings. The texture quality is low as well. And in this last benchmark, maybe not last. We're going to find out. Maybe if we can push more, we're gonna push more. Ray tracing lighting medium, of course, so ray tracing was set at medium, but I enabled the reflection on because it was off, and of course DLSS at ultra performance. Let's go ahead and have a look. Look at this. Let's go ahead and have a look what we can achieve over here. Okay, we go ahead and apply that. Here we go. Your eye at the left top corner, guys, VRAM and system RAM. Wow, this is unbelievable, guys. The performance of the Titan RTX is unbelievable. Look at this. And we can still push it. We can push it farther, guys. Wow. Maximum reflection on, so pretty much retracing is on, but lowest possible settings. What about if I'm going to enable the textures at high now, the texture quality at high, and we're still going to have like retracing quality just like this? Everything else will be at lowest possible settings, but texture quality at high. Is it going to be runnable? Let's go ahead and do that. Why not, guys? This is the only one. I know this video is pretty long, but this is the only one probably test 12K resolution on YouTube for a very long time, and this is the first one. I owe you this, so I'm going to go ahead and do that. Yeah, the next, we're gonna do one more. The texture quality will be high now, because right now the texture quality is low, as you can see by his fingers, by his nails, and tattoos is not that detailed. It's kind of blurred out. 9 FPS was still to go. I still have some capabilities. I have some room to breathe. As again, it's not playable, but it's bingeable. Wow, on the gaming rig, guys, on my i9-9900K 5.3 GHz, I'm assuming it's gonna give me about 13 FPS over here at these settings. But we're going to find out. I'm going to try to push it. 5.3 GHz on that i9-9900K, so it's 5th generation of the CPU, and next generation is pretty much boost up to 3%, minimum 3% at the same frequencies. So 5th generation, 50% boost, just if I'm going to run my i9-9900K at 3.2 GHz. So it's 15% boost over this CPU, but my i9-9900K running at 5.3 GHz, which is additionally 2000 MHz per each core, or 2 GHz per each core. So I'm assuming we're going to be having here 13-14 FPS just by CPU overclock, and because it's 5th generation ahead, based on my algorithms and calculations. But look at this, at low, not bad, but as again, the details of the tattoos is not there, but still not so bad. The game doesn't look that bad. I know the game looked like a template game. It's still looking like Watch Dogs or GTA. It looks like GTA actually 4, guys. The quality of the game. If we're going to just put somebody here that plays GTA 4 from the 2009 on this game, and we're not going to tell him, look, there is new technologies, retracing and RTX and stuff like that, and here and there, he probably not gonna tell you the difference, guys, to be honest with you. So they didn't improve in terms of the quality. The characters still low polygon characters, as you can see, and yeah, the quality is not here. There's nothing. The retracing right now maxed out, and maxed out retracing. Look, we can fake these bottles without the retracing API, without the retracing features, to make it lookish like that. I don't see a big difference, okay? To be honest with you guys. But with the maximum retracing, wow, this is unbelievable. And look at this bug. Remember that I told you there is a bug right there that doesn't reflect completely. It disappears somewhere. That's strange. Probably when you're changing the settings, you gotta reboot the game. And when I start rebooting the game, every single benchmark, every single test that we did during this video, it helped out. So maybe it's not the bug of the DirectX 12 retracing API by the DXR by the Microsoft. You just gotta reboot the game after you change the settings when you're using the retracing. There is a possibility. But I did the tests right during this benchmark. I was rebooting the game, first resetting the settings and rebooting the game. So beautiful. Okay, let's go ahead guys and do the textures at high now. If it's going to survive, we're gonna push it farther. I'm going to push the next thing after that. I'm going to push every single preset at maximum visuals. Let's go ahead and have a look, shall we? Alright guys, I'm back. The preset set. I rebooted the game. As again, I don't know what is the outcome will be. This is my first time doing that, so we're doing it together. And keep in mind, as again, it's recording with NVIDIA Shadowplay software on the same computer, so please add 3 FPS, but at least 2 FPS to the FPS counter to the left top when we're gonna do any benchmarks. So I set the quality texture at high now. So let me zoom in actually. Let me zoom in. Texture quality at high, okay? Everything else at low. If it's going to survive that, if it's not going to overload our VRAM and not going to crash, VRAM overload will be when you're going to see 1-2 FPS constantly. This is VRAM overload pretty much. And if it's not, if it's going to survive, we're going to push it farther. Okay, so this is what's up, guys. And ray tracing lighting at medium. Can you believe this? 12K resolution on a single video card. Turing GPU architecture by NVIDIA. Titan RTX. This is what's up, guys. DLSS ultra performance. Okay, let's go ahead and have a look. Video is again 12K resolution. Let me go ahead and enable that. Let's go ahead and have a look, shall we? Hopefully it's not going to crash. Okay, guys, respect my time. Don't forget to smash that like button. Share it with your friends. Subscribe for more great videos. 9 FPS, still 9 FPS. Wow. So pretty much, as I told you guys, that the textures at preset quality at low and high, pretty much the same deal. There's no such a big difference. Look at this. I don't see the dots on the mirrors edges. So the ray tracing is much better right now. Less noise though. 9 FPS, so pretty much FPS almost the same with the texture. I can see some noise on the table though. The texture quality low or high, pretty much the same deal in terms of the FPS. For Titan RTX it's like nothing, it's just going to eat it like it's nothing. Just chewing it like it's wow. Look at this, 9 FPS. But the VRAM is increasing, 22 right now, solid 22,000 megabytes at the left top corner. But the system RAM is kind of almost healthy. We probably still offloading some data, about I think 600 probably megabytes into the system RAM instead of VRAM. But that's not bad. When the data offloaded below 1 gigabytes, the FPS will be almost as same as without the offloading some data from the VRAM into the system RAM. Keep that in mind. In newer games, NVIDIA drivers does a great job when it's offloading some data from the VRAM into the system RAM. When the percentage of that offload is low, like below 1 gigabytes. When it's above 1 gigabytes, we start losing the FPS and the milliseconds latency delay is increasing. Look at that beautiful texture. So you can see the texture quality at high because his texture, but still no nails. He doesn't have no nails, look like, but still his textures are high quality now. Okay, 9 FPS, still great FPS. I think, guys, I'm going to go reflection at high now because this is reflection on medium. But before I'm gonna do that, I wanna crank up everything at maximum possible quality before we're going to crank up the retracing. Not the reflection, I mean the retracing quality right now at medium. And look at that. But tattoos right now are so visible. We can see the high quality tattoos right now, right? Wow, look at that. Just look at that. Look at this mirrors. Retrace mirrors. But where's my shadow? Huh, I don't have my shadow. Is this the retracing? Come on, what kind of retracing is that? Fakeish retracing? But as again, retracing on medium. Let's go ahead and find out. Retracing at high. The purpose of my video, guys, to show you the honesty. So it's not like those high school kids that faking it. They do not understand that karma will get them one day. And the purpose of my video to show you the things, bring you the value with my information, so you will decide and you will do your own analysis and you will decide what is the best for you. The texture quality at high, okay, but still it's kind of same, almost same quality on the tattoos. And see that big improvement. I probably need to crank up the whole in-game quality to the maximum. This is what we're about to do. So guys, just because we're not crashing, I'm just going to go ahead and cover all kind of presets at 12K resolution. Why not? And as again, if 16K resolution will be possible, I'm gonna do that as well. Alright, so we saw it, right? We saw beautiful visuals, by the way. That 12K resolution, the visuals are beautiful. So at least watch this video 4K resolution and try to switch this video to 8K resolution, because I'm going to upload it in 8K resolution, because I'm recording today with NVIDIA Shadowplay that is hacked, and I changed the values of 3840 by 2160 in the System RAM Debugger tool while it was in the runtime of the NVIDIA Shadowplay to 8K resolution recording, and it's recording without any issues. As again, you gotta add 3 FPS to the FPS counter. Very amazing performance. Let me go ahead and change the settings now. Everything at maximum possible preset, but the retracing still at medium. I will see you guys in a second. Alright guys, I'm back. I'm just set this insane quality now. Let's go ahead and have a look. If it's going to boot up, then Titan RTX is a golden video card, and it is Turing GPU architecture. And if you're watching this video, you're probably smart, and you probably, if you're on a low budget, you probably want to buy this video card in the end of 2021, in the beginning of 2022 for $400, used like new on eBay from the seller that sold over 1,000 items. You're gonna be Gucci. So everything's set to the maximum possible visuals. The texture quality is high. Check it out. Maximum possible visuals. Motion blur though is off, because we don't need motion blur when our FPS is so low. Screen space reflection quality psycho. If you're gonna boot up like this at 12K resolution, I'm going to be impressed. Retracing lighting at medium. Okay, so this is what's up, guys, over here. This is how we're rocking right now. Let me go ahead and zoom out, and let's go ahead and test that, shall we? Come on, let's cross our fingers, please. Oops, that's it. I think, guys, we got it. Houston, we got it. 0 to 2 FPS. Yeah, this is VRAM overload clearly. 23,000, almost 24,000 megabytes of the VRAM at the left top corner, and almost 15,000 megabytes of our system RAM usage. So we're about 28 gigabytes of the VRAM usage, I would say. But the only way to find out when I'm going to test this test with the 36 gigabyte of the VRAM video card, probably in 2022. Look at this. Yeah, this is clearly VRAM overload. That's it. I'm pretty sure we probably can handle with the GPU performance, computing performance, but not with the VRAM. And NVIDIA had the Titan XP, the CO version, which came with the 32 gigabytes. They also had the Titan Volta with 32 gigabytes of version. Maybe they have the Titan RTX CO version with 32 gigabyte of VRAM. And if this would be the case, I just dream to test this over here, because I think we probably around 5 FPS probably in terms of the GPU computing performance, if VRAM would be like 32 or 36 gigabyte on board of the Titan RTX. Look how beautiful it is. The visuals and everything. This 12K resolution is not a joke. Look at this. It just woke up, and is again, this is happening like this. Sometimes the game is waking up, and when a lot of data offloaded into the system RAM, and look at my system RAM, 17,000 megabytes. It's about to crash though during that point, and it's woke up at some point. We got a lot of data loaded into the system RAM. We just saw 17,000 megabytes, right? And we got offloaded some from the VRAM back to below 23,000 megabytes of our VRAM usage. But as again, it's not enough, and the game is still stressing. It's still stressing. There is more data coming out of this retracing. I think we got it here, guys. At this point, look at my milliseconds latency delay, about 1000 milliseconds. That means that we're almost at the point when we're going to crash. That means that we're offloading about 5,000 megabytes from the VRAM into the system RAM. Usually this is a signal. As I told you, throughout my algorithm and experiences, based on the Titan X Maxwell GPU architecture, when I had the 4 Titan X Maxwell GPU architecture in this lab back in 2016, then Titan XPs, I had 4 Titan XPs, but 4 Titan XPs actually was flickering the screen, and only 2 Titan XPs in SLI was running without the flickering the screen. And yeah, I had the 2 GTX 1080 Ti in SLI, 2 RTX 2080 Ti in SLI, guys. I had the 4 Radeon Fury X or 2 Radeon Pro Duo with 2 Radeon Fury X GPUs on board of each Radeon Pro Duo. Look at this again, woke up, okay, that's nice. Still NVIDIA driver. Look at this beautiful software developers at NVIDIA company. Nothing like we can say something like that about AMD. They have a horrible software development team. The AMD, in terms of their RX video cards, guys, just do not buy it. It's completely garbage, and at the retracing performance, it's much lower performance when comparing to RTX. But look at the reflection and refraction of that metal, of that retracing on his fingers a couple seconds ago was amazing. Scratches right there, even at the maximum performance on the DLSS. But the visuals is right on, guys. This is maximum possible visuals. Psycha even on the screen reflection preset. So it's completely maximum, and medium on the retracing. This is excellent for the Titan RTX video card, and it's waking up even. Wow, I cannot believe it. But still at 2 FPS. Yeah, that's about it, guys. That's about it. I will try for our experiment, I will try to set the retracing to high instead of medium. It's going to be the last test after this test. And that's it, just to see what will be our VRAM, so we can compute the total VRAM usage by combining the system RAM usage. As again, the system RAM usage should be below 11,000 megabytes. So at least we're utilizing right now almost 4,000 megabytes of our system RAM. Above what it should be means that offloading 4 gigabytes. Still below 5,000 gigabytes. I think the crashing happens under the NVIDIA driver when the VRAM, when the offloading data from the VRAM into the system RAM is above 5,000 gigabytes. At that type of scenario, somewhere at that point, probably 6,000 megabytes or 6 gigabytes, somewhere over there is crashing. The whole Direct 3D surface, in our case, Direct 3D 12 surface of the Direct 12 API. Beautiful visuals though. Look at this, it's just unbelievable. But still that retracing doesn't look like real. Look at these bottles right there. It doesn't look like a real retracing to me, like real life retracing, even if they claiming it's going to be like real life lighting and reflection and refraction. But those bottles on the back of his bag doesn't look like so to me. I don't know, it's lookish to you guys. It's still fake. So what's the point when we can fake it by baking textures versus the retracing? I mean, yeah, retracing is kind of nicer, but it's not there like in real time, real life, kind of not real time, but real life reflection retracing. It doesn't look like real life to me, guys, to a graphics designer, to be honestly. It's still losing that. It's not physically correct. They claiming it's physically correct. I don't think so, to be honest with you. Kind of close to the physically correct, but not totally physically correct, because those bottles over there should support the transparency better than it is right now. Yeah, so it doesn't matter, guys, during this guy or when I'm going to walk, the FPS will be 1-2 FPS anyways. As you can see, it's solid. We kinda dropping somehow. I think NVIDIA is managing through the artificial intelligence to compress this data better. That's why we're dropping the system RAM, as you can see, utilization to lower values right now, below 14,000 megabytes. And this is when the point of the system waking up happens, but it's still not enough, and then we still overloading it, so AI cannot predict correctly, I think. Yeah, but amazing performance. Imagine something like this on the AMD video cards. It's unbelievable. They cannot handle, they cannot even handle like this at 8K resolution probably with the retracing on, I'm pretty sure. This is solid performance, unbelievable performance. Come on, dude. So I mean, guys, that's it. It doesn't matter if we're going to finish our conversation right here. It's just going to take that time, but it doesn't matter. When I'm going to be right now watching those folks right there, it's probably going to be just the same deal, the same FPS. But let's go ahead and have a look real quick just to make sure for those naysayers. And then I'm going to go ahead and do the retracing too high. We're probably going to crash it, or if we're not going to crash it, we're going to see some values. Because as again, this is for PC enthusiasts over here anyways, for the PC gamers, and you can compute. I already explained to you the algorithms that you can use to compute this, the whole deal. Alright. I wanna go, man. I wanna go. Finish up. Okay? Look at this visuals though. Wow, the visuals is like... This is ¿Qué paso? ¿Por qué trabajo? Right here. Don't you think, guys? Check it out. Check it out. Yeah. Beautiful. But still, the tattoos should be better than that, I think, on the skin. Yeah, this is what's up, guys. This is look at this, 8 FPS. It's woke up. 9 FPS. Oh my god, no way. And I'm still talking to that dude, but it's woke up. We lower our latency delay to 100 now. 100. Wow, it's woke up. So I think it's compression ratio. The AI actually handling its compressing. I think all what's going on is just compressing it correctly at some level, as you can see, kind of predicting and compressing. But as again, it's just at some point it's waking up, but I don't think so. The whole game is gonna wake up at some points, but it's not going to wake up at completely, I think. There's no way it will do that. Yeah. It's just at some point, but it's not going to be benchable at all. Look at this, wake up again. Come on. Oh my goodness. No way. Oh my god, thanks god that we waited. Actually, look at this. AI is handling. Wow, NVIDIA, such a genius software developers, NVIDIA. Jensen Huang is just such a genius, guys. This guy has deserved all the Nobel prizes and even the Oscar. Look at this. I can play 9 FPS. It's woke up. NVIDIA driver is handling it. Yeah, at some point of the cutscenes it's going to be like that, but it's woke up. It's woke up. Let me go ahead and yeah, and it's holding it, guys. NVIDIA AI probably pre-calculated and find out the proper compression rate, and somehow it's low our system RAM usage below 13,000 megabytes, as you can see at the right top, and our VRAM usage is also, I'm not sure what magic NVIDIA is using over here, but this is amazing. But I saw their magic previously on Titan XPs when it's waking up. Go ahead and watch that video of the Aliens versus Predator when I was running Titan XPs, GTX 1080 Ti and SLI to GTX 1080 Ti and SLI. When I was running the 4 Titan X Maxwells and SLI, Aliens versus Predators, it also was that type of scenarios when the driver kind of pre-computed, probably was using the higher compression. I'm not sure what's going on, but what kind of magic NVIDIA is using. Even as a software developer, I cannot understand what are they using here, but whatever they're using over here, it's working great, guys. It's just right on. Wow, it's just unbelievable. Alright, so one more task, guys, one more task. This video will be over 1 hour. YouTube going to hate me so bad. They hate me already, but I will try to upload it in 8K resolution. Well, we'll see. If the video will be below 100 gigabytes, I'm going to upload in 8K resolution. If it's going to be above 120 gigabytes, I'm going to upload in 4K resolution. But at least to watch at 4K resolution on the screen, like 12-inch screen at least, guys, to see all the details. So I will see you guys in a second. I will set the reflection to high. I mean, not the reflection, but retracing. In 1 second. See ya. Alright, guys, I'm back. Set the crazy preset and rebooted the game. Let me zoom in, and look like this is going to be the last test for sure. If we're not gonna crash, or even if we're gonna crash, this is going to be the last test, because pretty much we overloaded our VRAM to the maximum possible. We overloaded the whole system, as you saw. We pushed the system to its knee. So what I did, of course, texture quality at high, every single preset at high, as you can see, except the motion blur at off, at screen space reflection quality cycle even, wow. And right here, retracing quality I set at ultra instead of medium. Okay, this is only the difference, but still DLSS at ultra performance. Of course we can improve it. This is the highest possible FPS, but we already at the point where, you know, this is probably, if you would be running like that, this is probably how you would be running. Okay, so let me zoom out. Let's go ahead and have a look. Cross our fingers. Hopefully we can see the performance before the game is going to crash. But I think it's going to be 0.10-1 FPS constantly. Well, let's go ahead and have a look. Yeah, look at this. The game is not even waking up. Here we go. Look at this. Okay. So the lighting right now is set at ultra. So there is no high preset. There is a medium and ultra. So maybe the ballast on the back of his back, of this character back in a second, will be much better, because the lighting right now at the maximum possible performance. We'll see how the ballast will look like, if it's going to be close to real life retracing photorealism, yes or no. But FPS, 1 FPS, VRAM utilization almost 20, yeah, already 23,000 megabytes. The system RAM utilization is almost 14,000 megabytes, but it's going to go up. Let me lift up my head, and when we're going to load up more 3D world in our camera, yeah, and we as you can see, VRAM utilization is raising up, the system RAM utilization is raising up, but everything is just wow. Look at this, the textures, everything is great. And the retracing capabilities, guys, over here is set to the minimum. Keep that in mind, because the maximum performance or ultra performance is the minimum retracing capabilities. I mean, all the features are enabled, but the resolution of that retracing capability is set to the lowest possible. Okay, this is very important to understand. And because ultra performance, and the quality will be the maximum possible retracing capabilities in terms of the resolution, because it's still using the images. It's creating that world into the images, and then it's reflecting based on that in real time. Not just a few objects, but the whole 3D world should be retraced. Wow, look at that. Wow, the visuals is like, it's like a Pixar movie actually. I cannot wait to see it in 16K resolution, even at the lowest. It's probably going to be amazing, because 12K resolution like that versus the 16K resolution, I can see the difference on the 8K resolution monitor. Look at this, we just woke up at 7 FPS. Comparing to that at medium retracing light was 9. Right now it's 7, and we woke up, guys. We woke up. We unleashed some. We decreased some VRAM utilization and decreased some system RAM utilization. But as again, it's probably for a few seconds when AI is kind of found the repeating cycles. I believe it's happening when the NVIDIA AI on board see the repeating cycles, and it's just processing through the GPU those cycles and through the VRAM, and probably maybe some skipping some cycles, pretty much do the VRAM garbage collector faster than it is and utilizing less VRAM. I see it as a software developer. I think this is what's going on. But system RAM utilization almost 19 gigabytes. Did you see that? 18,000 megabytes was in a second. I think with 7 gigabytes of loading VRAM, we're about to crash. So it's supposed to be about 30 gigabytes of VRAM utilization, but instead it's 23,000 megabytes, and the system RAM utilization was 18,000 megabytes. But still, it's lowering itself down. NVIDIA driver is capable to handle the situation. Right now, I think the retracing is much better, guys. In the back of his back will be. Look at this. It just, wow. This render is unbelievable, and it's still happening in real time. Compare something like that in 3ds Max Studio, guys. I'm creating a beautiful bacteria tutorial when I'm going to teach you in 3ds Max Studio how to 3D model easy objects, how to texture them, how to set light, and how to animate them, and how to create them into the final video. And 3ds Max Studio, to create 8K resolution 30-second video clip, just 20 bacteria flying, which is also retracing, took 4 days on a Xeon E5-2697 V2 CPU in 8K resolution, or 800 by 600 took, no, I mean 1280 by 720 pixels took 1 day, took like 24 hours of 30-second clip. And this is retracing going on in real time, and the retracing quality, look at this arms, fingers, almost the same as 3ds Max Studio. But 3ds Max Studio, every single frame in 8K resolution takes like 5 minutes to render, 3 to 5 minutes. I'm going to show you that tutorial. We're probably going to use that tutorial as well as benchmarking of the CPUs in the future. It's a great video coming out over the USGKing.com YouTube channel, or iplay16k.com, or artisticbytes.com. You don't want to miss it. That tutorial going to underline a lot of knowledge if you're trying to learn the 3D modeling, 3D animation using the 3ds Max Studio. And I'm going to cover it. I'm going to cover the 15 years experience in that software since 2004. Everything what I learned in about like 3 hours of tutorial. And it's going to be for a beginner. Every single step will be explained to you. It's going to be like 3 hours tutorials, like you read 2 books after watching that tutorial. So don't miss it out, guys. Look at this. Yeah, right now bottle's kind of getting better reflection and refraction in the back than it was before. Yeah, really like it. The skin tone, look at this. At some point it's reflecting and at some point it doesn't. It wasn't like if the texture would be pre-baked, it's going to be reflecting at all the points. That's what it takes, that skin tone on this character. That was takes that retracing. So retracing is still bringing that cinematic quality of the visuals, but still at what kind of cost? Look at this. The visuals in terms of the polygon count of the topology of the 3D models, it looks like low polygon. It's still this character. What? This character probably like a StarCraft 2 character. I think it's like 20,000 polygons, maybe at maximum 30,000 polygons. This character. So I would say the whole scene in this building, probably 2 million, maybe 3 million polygons, just like a Crysis at the maximum. Crysis 1 PC game at the scene, like island, in the middle of the island with the characters and stuff, probably the same amount of the polygons count. So they still like in 2007 with the retracing, because they're lowering the polygons count to be able to push that retracing capabilities on the GPU because it's heavy. And why are they doing that? Because the AMD video cards is not capable to support it, and they utilizing their unified shaders when NVIDIA utilizing the RT cores. So the developers want to make sure that their games are capable to be executable and runnable on both technologies, AMD and NVIDIA. But I don't think even NVIDIA is capable to push higher polygons counts over here. I think it's not, as again, it depends what resolution we're talking about. But yeah, it's as again, guys, you saw what's going on, right? It just, ¿qué pasa? ¿Por qué trabajo, muchacho? This is what's going on. ¿Qué pasito, mandarito? Okay, otherwise I don't know how to say it. This is what's going on. I mean, we need to have probably quadros here. At least quadro will be fine here. Guys, send NVIDIA a note. Go ahead and write NVIDIA. Tell them that USG King, I play 4K, aka I play 16K, needs that quadro, the newest quadro, with a lot of that VRAM, because he cannot afford it. I need your support, guys. Buy my merch. If you want to see some hardcore from a professional like me, 3D artist, graphic designer, PC enthusiast, PC overclocker, support me. Buy my hardware. Support me. Even couple dollars can end up, and instead of the next RTX 3090, even the RTX 3090, you know, I was like, I cannot, guys, buy $10,000 computers every year. It's so much money. I already invested in YouTube channel almost $15,000 since 2016 over this 4 years of period of 4 years, just to show you what it is. So at least appreciate, smash that like button, visit my sponsors on the ads on the YouTube, and you know, donate as much as you can, even $1 over my YouTube channel. Buy my merch. I'm going to release the brand new merch, Quake 3 cinematic mode logo that I designed, and Quake 2 cinematic mode. The Quake 2 cinematic mode that I'm working, that's going to bring the retracing to another great heights with the much better visuals that Quake 2 RTX by NVIDIA. I'm going to bring the classic rail in Quake 2 RTX that was missing in Quake 2 RTX, classic from Quake 2, but it's going to be fully retraced, that classic rail, and much better materials in my Quake 2 RTX cinematic mode. Check it out over modedb.com. Just Google Quake 2 RTX cinematic mode. Or in my Quake 3 cinematic mode, I'm going to bring textures and that will be ready up to 16K resolution gameplay, redrew by 7 of AIs, 2 commercial AIs and 5 open source AIs, and my retouches. The Quake 3 Arena with cinematic mode will look amazing. Go ahead and check it out. And I'm going to do my merch, my hoodies and t-shirts with Quake 3 cinematic. It's going to be a beautiful logo, you don't want to miss it. Buy a premium t-shirts you're going to enjoy, or premium hoodie, and or just the cases for the iPhones. I cover all the iPhones. It's going to be a great designs are coming out. Just support me, guys, or donate as much as you can. This is where you want to donate, not to the Linus channel and some other channels that even without your donations they sponsor. They have money overflowing there. They have so much stuff. They're doing nothing, laughing and showing you some stupidity on their free time. This is how much money they have. Versus me, when I'm wasting my time and I'm bringing so much value every single second from different angle of developer, software developer, graphics designer, gamer, PC hardware enthusiast, PC overclocker. You just learned a lot of information, and I'm trying to give you this information like even for the beginners, so anybody can understand it. So as again, don't forget to smash that like button and support me as much as you can. Share it with your friends. This is the beautiful video, and hopefully I can push this hardware to 16K resolution. Probably not, because even at low we were like 20,000 megabytes of VRAM usage, and 16K resolution will take another 2,000-3,000 megabytes of VRAM. Maybe at lowest quality of everything, maybe we can handle 16K resolution. We're going to see it. Maybe not, but check it out. It's just beautiful, guys. I'm just waiting when the conversation will be over, so we can go ahead and walk out a little bit and see if it's going to wake up. But it doesn't look like it's going to wake up, because as you can see, the overload is at the point. I think it's about to crash the whole game, but hopefully not. And as again, this is why I'm recording with NVIDIA Shadowplay software on the same computer, and NVIDIA Shadowplay software by NVIDIA is also utilizing my video card resources. Keep that in mind. But the FPS, you cannot add at this scenario 3 FPS to the left top corner. Just add 0 at this scenario when it's 1 FPS. But 3 FPS at all the different tests. Just go ahead and do that. This is what NVIDIA Shadowplay takes while it's recording in 8K resolution native. But it doesn't matter when NVIDIA Shadow recording 4K resolution or 8K resolution, guys. It's just the same FPS taking in terms of the performance. NVIDIA did a great job, and this is what AMD Radeon video cards are lacking. They're lacking the hardware acceleration screen recording. They're still recording the screen with the software, which will be 4K resolution, lagging, and takes a lot of performance of your system, while NVIDIA is using the hardware acceleration when it's recording the screen. And because they have a beautiful software engineers and hardware engineers as one team. So guys, I have no doubts that NVIDIA will have a great future with their ARM CPUs. And I was the first guy that told you that in 2018. I told you that ARM and Apple company will dominate PC gaming and console gaming in 2027 with the A18 chips, A18 Bionic chip, and that A18 Bionic chip will be as fast as M2 chip, much faster than M1 chip. And right now, Apple with the M1 chip is already dominating in terms of the CPU performance. Even the Ryzen 5950X. It's faster than 5950X NVIDIA encoding. Can you believe this? They're already dominating, and that M1 technology, ARM chips by Apple, will come to the iPhone and iPad, such as probably A16 chips in terms of the power, same performance, Bionic chips, and A18 chips. This is where exactly 2027, when you will stop playing console games, stop playing the PC games, and you will have a little device in your pocket, and you will be able to connect it to the TV through the wireless, through the Bluetooth, or through the just a simple cable without any compression, and you can play by yourself a gamepad. Even right now you can do that, and already the visuals on the Apple iOS devices almost as similar as this visuals, and I will compare it to you guys. I will show it to you running on the metal. So already we can see that by this game I can tell you guys that PC gaming is dead. Look at this, they still using the same templated frameworks as you can see, and there is nothing new except the ray tracing. Look at this, it just woke up 8 FPS. Wow, Titan RTX is golden. Look at this, the NVIDIA software developers are unbelievable. NVIDIA hardware developers are unbelievable engineers. This is unbelievable. This is just unbelievable. I just woke up at 9 FPS and I think the AI just took somehow. I'm not sure how they're doing that, but they probably compressing a lot of data, because we can see the system RAM utilization went down and the VRAM utilization went down. But look at this, I'm running healthy 9 FPS and I'm not healthy VRAM utilization, but still probably offloading about 3 gigabytes. But still that FPS is crazy, and latency delay is not 1000, it's in high hundreds. But this is just unbelievable, guys. Everything is ray tracing capabilities right now running maxed out. 12K resolution. The AMD video cards cannot run this at 8K resolution, guys, at all. Let me go ahead and have a look. Is it any reflection? Nope, I don't see any reflection, buddies. This reflection is fake, it's not retraced. But anyways, not retraced in real time at least. It's pre-baked texture. But look at this. Guys, this is just unbelievable. Look at these visuals. The texture at high as well. Wow. Wow, guys. Alright guys, I guess we're going to go ahead and wrap it up. Unless you want to see the crash. Okay, let's go ahead and max out. Let's go ahead and finish this test, shall we? Let's go ahead and max out. I'm going to go ahead now and I'm going to use what? Everything is maxed out right now, I think. There's nothing else what I can do. This is a maxed out running. 12K resolution. It's woke up. Yeah, I think there is nothing else we can do, guys. It's running maxed out. Retracing maxed out, visuals maxed out, everything is maxed out. This is just wow. I mean, this is just wow. Wow. Alright guys, don't forget to smash that like button. I play 4K what we do today, aka I play 8K, aka I play 16K, or UHD King. We are using 8K resolution native screen plus NVIDIA DSR technologies to bring it to 12K resolution. Hopefully I'm going to introduce you to 16K resolution on the Titan RTX. If not, I will try to do so on the RTX 3090. And have a great day, stay safe, be smart, till the next time.